Hello and welcome to Toppers Town. In this video, we will know about the very first chapter of NCERT physics, that is electric charge and fields. The first topic is quantization of electric charge. Many experiments are made on this, like Millikan's oil drop experiment. Show that electric charges are found to be made up of integral multiple of the smallest amount of charge. That is, electric charges are made up of integral multiple. That means either they have negative charge or positive charge and not in the fraction. No charge is found in fraction. Electric charge cannot be divided indefinitely, and this property of charge is only called the quantization or atomicity of charge. Some particles are as follows, that is, charge of electron is minus E and charge of proton is plus E, and charge of alpha particle is equal to plus 2E, that is positive 2 electrons are present. The second topic is conservation of electric charge. Many experiments and many other phenomena show that the total amount of charge in an isolated system remains constant. It means that charge can neither be created nor be destroyed. This is only called the law of conservation of charge. For example, in radioactive decay, the uranium nucleus is converted into thorium nucleus and emits alpha particle. Thus, the total charge plus 92E, that is positive 92 electrons, that is 92 positive electron, both the before and after. Today's topic is Coulomb's law, uh, which is very important topic of the first chapter. In 1785, Coulomb, on the basis of experiment, gave a law regarding to the force acting between two charges. According to this law, two stationary point charges repel or attract each other with a force which is directly proportional to the product of the charges and inversely proportional to the square of distance between them. What is said in this law is when two charges in the same line, that you can see on the screen diagram is also given, that q1 and q2 are placed as a certain distance, they repel or attract, and force produced during repulsion and attraction, that is only directly proportional to the product of the charges and inversely proportional to the square of distance between them. This is all about the Coulomb's law and nothing else. We will also go through the derivation of this law, that F is directly proportional to Q1 Q2 upon R square. So for removing directly proportional, we can place is equal to and multiply by K with the F, that is F is equal to K into Q1 Q2 upon R square, which is equation 1 of Coulomb's law or this derivation, where K is proportionally constant and value of K depends on the unit used for charges, distance and force. Charges are Q, distance is R and force is F. So if the charges are placed in vacuum or in air, then for convenience the proportionality constant K is in equation 1 is written as 1 upon 4 by epsilon naught. Hence F is equal to 1 upon 4 by epsilon naught Q1 Q2 upon R square Newton. This is the formula we get. And you should remember one thing in physics, that in each formula there is a new symbol, and each symbol has its own name, meaning and value. In same wise, in the formula F is equal to 1 upon 4 by epsilon naught Q1 Q2 upon R square Newton. Epsilon naught is a new symbol which is called permittivity of free space, and we can find its value by putting 1 upon 4 by epsilon naught, whose value is 9 into 10 power 9 Newton meter square per Coulomb square, in the formula of equation second, and we will get epsilon naught is equal to 8.85 into 10 to the power minus Coulomb square per Newton meter square. In equation 2, The surrounding medium was vacuum. But when the surrounding medium is some illustrated material and not vacuum, like glass, wax, paper, anything, in which the charge are being attracted or repelled, then equation second becomes F is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square. This time epsilon naught is removed by this time epsilon naught is replaced by epsilon, that is absolute permittivity of the material medium, and epsilon is slightly larger than epsilon naught, so epsilon is equal to K epsilon naught. Here K is capital K and its dimension is constant, which is called dielectric constant or relative permittivity. You should notice one thing, that in equation 2, before equation 2, uh, one k was used, that was small k, and it was proportional constant, but the k used here is capital K, which is dielectric constant. That's all. Thank you.
Please like, share and subscribe our channel and press the bell icon.